Right, this video I'm gonna talk about how to specify the adsorbent properties. So last video we discussed how to provide properties for the adsorbate, which are gaseous molecules, and adsorbents are the solid particles or the where the adsorption is taking place, right? So typically these adsorbents are consisted of pellets, which the pellets are made out of the adsorbent particles, which has capacity to hold these gas molecules on its surface or within its micropores, and binder to hold these together in certain types of geometry, such as cylinder or sphere. So the first thing we need to specify is the diameter of the pellet. We assume spherical pellet. Really, the geometry doesn't matter in our simulation in toPSAil, so we just assume it's spherical pellet, so you specify the diameter for the pellet. This particular parameter is important, especially when we model the pressure drop, because the Argon equation or Kojanik-Harman equation has this parameter in it. So void fraction, so here we're actually specifying which part of the adsorbent is responsible for being in an adsorbed state. So basically there's different breakdown of gas phase and the adsorb phase, right? So the question here to ask is, what is controlling the mass transfer resistance, right? What is the controlling process? So if there's like a boundary layer and pellet skin, then the resistance is controlling pretty much everything within the boundary layer of the surrounding this sphere would be considered as an adsorb phase. If the macropore, which is relatively larger pores than the micropores, are controlling, then everything or any gas molecules within macropores considered to be adsorb phase. Micropores, micropore resistance is controlling, and typically in adsorption literature, whenever these gaseous molecules adsorbates makes their ways into micropores, then they're practically considered as a part of adsorb phase, and physisorption resistance is controlling in certain application as well. So by supplying these clicking drop-down menu and supplying the numerical number consistent with this description, you're just telling toPSAil which belongs to gas phase and which belongs to the surface. And as you can see, you can change this around, but depending on say the micropore resistance is controlling, then you actually need to specify few more parameters, the void fraction of the macropore and the void fraction of micropore. Sometimes you might have those experimental values available. If not, it's safe to assume that macropore resistance is controlling for the sake of our lack of knowledge about these parameters. Densities are also important, right? So experimentally, you measure in the lab the pellet density and the bulk density of the adsorbent pellet. So if you are ever confused, I defined all these density definitions in this help tab. So you should be able to figure out which density to provide based on this help tab. Isotherms are very important. So remember in the configuration file, we chose linear isotherm, and in this case, we just need Henry's coefficient. So you just have to provide a Henry's coefficient in terms of right units. Here's explanation as well. So all these grayed out ones represents parameters that you need for different types of isotherms, and depending on the isothermal and non-isothermal simulation, you need to specify more or less parameters. So these cells will get activated based on the configuration settings that you make in the earlier spreadsheet. Adsorption kinetics is simpler. We always assume linear driving force kinetics, so all you need to do is specify the mass transfer coefficient, which can be obtained from an independent set of experiments, or sometimes these are often used as tuning parameters to fit our PSA pressure profile to the experimental data. Thermodynamics properties. for non-isothermal simulation, we would be interested in specifying heat capacity of the solid adsorbent. Yeah, that's it. So we basically we try our best to provide the right descriptions, and then your job is to hunt down the literature and then provide these parameters with the right units. Thank you.